Hello everyone, this is Roshan Raga. Welcome to Microcontroller Programming with Arduino and Matlab. I'm making a series of screencasts as complementary material for GP106 Computing course. First of all, let's see what's inside the box. So the box has an Arduino Uno microcontroller development board, the breadboard or the prototyping board, some jumper wires for prototyping, the USB type A to B cable to connect or for connecting your Arduino Uno board with the computer. We have some LEDs, different colors. We have resistors, smaller one like 220 ohm and larger ones 10 kilo ohms. Then we have an LDR, the thermistor, an active buzzer, seven segment displays, two of them, plus we have some transistors, NPN, bipolar transistors. Let's have a closer look at an Arduino Uno development board. The board has the main component, the microcontroller. It's usually an ATmega microcontroller, and the USB port type B, where you can connect one side of the cable for type A, type B cable, and then you have the power supply. Usually we will not be using the power supply from here, we will be using the power from the USB port of your computer. And then you have two sets of pins. One, the digital pins, they are named digital, including the pulse width modulation pins, and on the other side you have some analog pins. In addition, you also have some ground and power different voltage pins. So to give you more details, here are the pins. This side is the digital pin side, where you have pin numbers starting from 0 up to 13, and then the ground pin. And on the other side you have you have the analog input pins plus the power pins like different voltages, 5, 3.3 and ground. Let's see how we can get started. We'll start by launching Matlab. At the same time, I'm going to take the microcontroller board or the Arduino Uno board and connect the board to my laptop. So that's one side, the cable. The other side goes into the USB port of my computer. When the USB port or the computer is connected, you should see that the Arduino Uno board should light this LED. That is to say that the computer is powered on, sorry, the board is powered on, and then you can start programming the board. Before you decide a program to be run on this board, you need to connect the board to your computer through a software connection using a concept called ports. So you're going to locate the port that has to be configured for such connection. So in your computer, go to Device Manager, look for ports, see Arduino Uno here, says COM88. So that's the port to which you have to connect your Matlab program or the Matlab IDE to the Arduino Uno. So COM port 88, remember that. So now let's try connecting. So I'm going to connect it at the command window. I'm going to give a name to my Arduino Uno board. The name I'm going to give is A, and the function I'm going to use to do the connection is Arduino and the port number COM88. If everything goes fine, I should have Matlab connected to Arduino Uno in no time. Let's wait for the connection. Yeah. So if everything goes fine, should get this message, Arduino successfully connected. Now Matlab is connected to Arduino Uno board, and the variable that holds the connection is variable A. Using this variable, we'll be able to perform computations or input-output operations from the Matlab interface to the Arduino Uno board. Let's see our very first example of how this can be done. So for the very first example, what I'm going to do is I'm going to show you how the board can be tested to see whether it's working with Matlab. So for doing so, I'm going to make use of one of the LEDs that is connected internally on the board to pin number 13, a digital input output port or pin. So what we'll do is first I'll configure the pin number 13 as an output pin so that I can send some signal from my computer to the board through the microcontroller. So let me do a pin mode, the command that is used for configuring a port, particularly a digital port, as an input or an output port. The name of the board, the pin number, set 13, and the mode. I'm going to call it, make it output. If all good, I should see I should not see any error messages on my command window in Matlab. Plus, now the board is ready to be tested. So let me make it a little more clear. Bring this closer. Right. So now let's write some simple commands to light the LED on the board and see whether everything works good. So for doing so, I'm going to use the digital write function Again it takes 3 arguments: the name of the board, the pin number, the value to be written. Given that it's a digital write command, the only values you can write using this command are either a 0 or a 1. So I'm going to write a 1 now to this board, through which I'll be sending a signal to an LED on the board. That's just here. For now you can't, we might not be able to see it, but when I'm going to light, when I light the LED, you'll be able to see it. I'm going to put a 1 so that LED will be lit. You can see it's lit. You can turn off the LED by giving a 0. You can keep on doing this. So that's a small program that can be used, or a small set of functions that can be used to test whether the board is connected to your Matlab program and whether you can write some commands to the microcontroller on the board. Right, now let's start prototyping. Let's start with a very simple example where I'm going to connect an LED to the digital out of the Arduino Uno, and then light the LED on and off. So to do this, I need an LED. I'm getting a green LED and a resistor to connect in series with the LED. I'm getting a 220 ohm resistor and some jumper cables. So now let's connect the pin number 13 of the Arduino Uno board is connected. Let me connect it to the board. From there, the LED is the long leg. The anode is going to be I'm going to connect the anode to the pin number 13. The cable coming from pin number 13, the jumper cable coming from pin number 13. From the cathode of the LED to the ground of the board via another jumper cable. Given that the connection is done, now let's code. I'm going to say Arduino COM88, the port to which the Arduino board is connected. Right, that's connected. Now like in the test program, we are going to set pin number 13 as a digital output pin. So I'm going to use pin mode, the board pin number 13 as the output. Now I can use the digital write command. Again, A pin number 13. If I say 1, the LED should lit, the green color LED, and when I say 0, the LED should go off. Now let's extend this program to do, instead of a digital write, an analog write. To perform analog write, I will not be able to use digital pin number 13, because digital pin number 13 is not connected to the pulse width modulator of the microcontroller, and therefore I'm going to change pin number 13 to pin number 11 which is a digital pin that's internally connected to the pulse width modulator, meaning I will be able to perform analog write operations through pin number 11. So I'm going to set, now let's clear the screen. Now let me set pin number 11 as again an output pin, because what we are doing is an analog write. From the microcontroller's point of view, it is a write or output operation. Now I can do an analog write with pin number 11, and an analog write can have or can take any value between 0 and 255. 0 meaning the duty cycle 0, 255 meaning the duty cycle of 100. So if I say 255 for instance, duty cycle 100, meaning the LED should get a voltage which is equivalent to 5 volts. You can see. If I say 0, the LED should get an analog voltage which is equivalent to voltage 0. If I say a value in between, let's say 25 or 25% of 255, which is about 64, I get 25% of almost like 25% of the duty cycle. I can also do the same by multiplying this by 0.25, which unfortunately is going to give me like a floating point number. So let me convert it to an integer by using the round function. So it will do very much similar to what the number 64 did. 255 into 0.25 is almost 64. So I can change this value, which is the duty cycle, to 0.5 for instance. I can get it brightened halfway through 0.75% and 100%. That's how the different analog signals can be given by using the pulse width modulator, using through the analog write function. So once again, in summary, the analog write function can take a value between 0 and 255. 0 meaning 0 voltage, 255 meaning 5 voltage. Anything in between, as long as it's an integer, you can give a number and get the corresponding voltage through the pin which are marked as pulse width modulation pins. Right. Now let's see how a 2-pin analog sensor such as an LDR can be connected to an Arduino board. We'll start by connecting the LDR in a circuit as shown here. So the LDR we have is about 10 kilo ohm resistance, and therefore we are connecting another 10 kilo ohm serial resistor, more like a potential divider, in which we'll be measuring the voltage at this particular point. By measuring the voltage here, when the resistance of the LDR changes with the light, the voltage value is going to change, which we are going to measure as an analog signal and be converted into the microcontroller as a digital signal using analog to digital converter. So the digital signal you get into the microcontroller is a value between 0 and 1023. Let's now build the circuit. I'm going to start with an LDR and a 10 kilo ohm resistor and some jumper wires. So let's first connect the circuit starting from 5 volt to the breadboard, and the other side of the breadboard is going to be connected to the ground. Now let's connect the LDR to the 10 kilo ohm constant resistor to 5 volt, starting from 5 volt, then from there the LDR to the ground. So let me connect it somewhere here. From there, take a wire from there to the ground. Right. So now we need to connect the point we want to measure to analog pin, a particular analog pin. In this case, I'm connecting it to analog pin 0. So the circuit is done. Let's start coding. The board is already connected as with a variable name A. So I'm going to do an analog read with A and the pin number. Remember that you do not need to set the pin mode here, as analog pins are only used for analog inputs. So let's run the command, and so you get some voltages. The value somewhere closer to 200 is what you are getting. Let's change the resistance of the LDR by closing a light source. You can see that the value has changed from 200 to 700. Now let's say I wanted to get this reading every 10 seconds and print it to the screen. So I need to write a small program for doing so. I'm going to open the Matlab editor and write a little program, a script. What I'm going to write is in fact an infinite loop. Inside the loop, I'm going to call the function analog read with port 0. So given that I want to do it every 10 seconds, I put a 10-second delay between each read. So this script is going to keep on running, taking reading from the variable A, which I have already started here in the command window, and print the output to the screen. I could have done something like this: the light equals, and then I print or display light, like that. Let's run the program, save it, let's see what happens. Every 10 seconds, the value at A0 is printed. I can now change the lighting condition of the LDR to see whether the value is changing. Yes. You also can make the code little faster by stopping this and putting a smaller delay like 2 seconds. Hiding the light source, showing the light source. So that's a small program. When run, it's going to run in an indefinite loop. Why so? Is because the condition for the loop is always true or 1, and keep on doing or measuring the light intensity or just the resistance and print the value back with a 2-second interval.